Every hour, the sun gives Earth more energy than humanity uses in an entire year. For thousands of years, we stood beneath it, warmed by it, dependent on it, but unable to control it, until one bold idea changed everything. What if we could capture the sun? For most of human history, the sun was a symbol of power and mystery. Ancient civilizations worshipped it. Farmers relied on it. Empires rose and fell according to its seasons. It provided warmth, light, and life itself. But despite its importance, humans had no way to store its energy or transform it into usable power. They could build homes to trap heat. They could align temples with sunrise. But turning sunlight directly into electricity? That seemed impossible. The journey toward that impossibility began in 1839. A young French physicist named Edmond Becquerel was experimenting in his father's laboratory. While studying chemical reactions involving light, he noticed something unusual. When light hits certain materials in a solution, a small electric current was produced. It was tiny, almost useless at the time, but it proved something revolutionary. Light could generate electricity. This discovery became known as the photovoltaic effect, the scientific principle behind every modern solar panel. Yet the world barely noticed. The Industrial Revolution was in full force. Coal-powered factories, steam engines drove trains. Oil would soon dominate transportation. Compared to roaring engines and burning fuel, sunlight seemed weak and impractical. Still, scientists were fascinated. In 1883, American inventor Charles Fritz created the first solid solar cell, using selenium coated with a thin layer of gold. It converted sunlight into electricity, but with less than 1% efficiency. It was groundbreaking, but far from practical. The science was there, but the technology wasn't ready. Then, in 1905, Albert Einstein published a paper explaining the photoelectric effect, how light can knock electrons free from atoms to create electric current. His work later earned him the Nobel Prize and provided the theoretical foundation for solar energy. Now humanity understood how sunlight could produce electricity. But understanding did not immediately lead to transformation. For decades, fossil fuels remained cheap and powerful. Coal plants expanded. Oil fields multiplied. Solar research continued quietly in laboratories with little public attention. Everything changed in the mid-20th century. In 1954, scientists at Bell Laboratories developed the first practical silicon solar cell. It achieved around 6% efficiency, a major improvement. For the first time, solar panels could reliably power small devices. Then came the space race. Satellites orbiting Earth needed energy. They couldn't be refueled. They couldn't rely on wires. They needed something constant and dependable. The answer was obvious: the sun. Solar panels powered early satellites and proved incredibly reliable in space. In a harsh vacuum above Earth, they quietly converted sunlight into electricity, keeping communication systems alive. Solar energy had proven itself. But on Earth, fossil fuels still dominated daily life. Then the oil crisis of 1973 shook the world. Fuel shortages exposed the dangers of energy dependence. Prices surged. Economies trembled. Governments began investing more seriously in renewable energy research. Solar technology gained momentum. Engineers improved silicon purity. Manufacturing techniques became more efficient. Gradually, costs began to fall. Environmental awareness also grew. Concerns about pollution and climate change increased interest in cleaner energy alternatives. Still, solar panels were expensive. The real breakthrough came with large-scale production. As more panels were manufactured, costs dropped dramatically. Technological improvements pushed efficiency beyond 15%, then beyond 20%. What was once an expensive experiment became an affordable option. Rooftops started to change. Homes installed solar arrays. Schools, businesses, and factories followed. Massive solar farms began appearing in deserts, covering vast areas with shimmering blue panels angled toward the sky. Today, solar power is one of the fastest-growing energy sources in the world. In many regions, It is now cheaper than coal or natural gas. Entire cities are powered partly by sunlight, and innovation continues. Scientists are developing flexible solar panels that can wrap around buildings, transparent panels that function as windows. Advanced materials like perovskite promise even higher efficiency at lower costs. The core idea remains simple. Sunlight hits a material, electrons move, electricity flows. But the impact is profound. Solar panels change humanity's relationship with energy. For centuries, progress depended on extracting fuel from beneath the earth, digging, drilling, burning. Solar power flips that model. Instead of taking from underground, we harvest from above. Instead of smoke and pollution, we capture light silently. Of course, challenges remain. Solar energy depends on weather and daylight. Energy storage systems, like batteries, are needed to ensure power at night. Infrastructure must adapt to renewable integration, but technology continues to advance. Battery systems are improving rapidly. Smart grids balance supply and demand more efficiently than ever before. And beyond technology, solar panels represent something deeper: independence. The sun shines on everyone. It is not limited to certain regions or controlled by a few nations. Every rooftop has potential. Every community can generate power locally. In remote villages without traditional power grids, small solar systems provide lighting, refrigeration, and internet access. Children can study at night. Clinics can store medicines safely. Entire communities gain opportunities that were once out of reach. Solar energy is not just about electricity. It is about possibility. From a curious experiment in a 19th century laboratory to vast solar farms visible from space, the invention of solar panels took nearly 2 centuries of persistence. It required scientists who believed in a fragile idea, engineers who improved it, investors who supported it, and societies willing to adopt it. Humanity looked at the sun, the same star that ancient civilizations worshipped, and decided not just to admire it, but to collaborate with it. We did not conquer the sun. We learned to work with it. Tomorrow morning, the sun will rise again, just as it has for billions of years. But now, when its rays touch rooftops, satellites, and cities, something extraordinary happens. Light becomes electricity. What began as a small scientific discovery became one of the most important energy revolutions in human history. From early experiments to global solar networks, humanity transformed sunlight into power. The age of fossil fuels shaped the past. The age of sunlight may define the future. And this time, the energy that drives our world doesn't come from beneath our feet. It comes from the sky. Some with face,